Good evening and good morning to wherever you are in the world. You're very welcome to another webinar in this State of the Science webinar series that's being run by the New Zealand Agricultural Greenhouse Gas Research Centre here in New Zealand. I'm really delighted to be joined by Chris Korihiki today as chair of this session. Chris is AgResearch's Urungi Māori Strategy and Engagement Manager, and I know how busy Chris is, so we're really delighted to have him here today to be able to chair this session. So without any further ado, I'd like to hand over to Chris. Chris, kia ora.
Kia ora, Sinead. E te iwi, aku nui aku rahi, koutou kua mene mai nei, tēnei te mihi atu rā kia koutou, piki mai, kake mai. Welcome everybody, visitors from New Zealand and people from overseas. Welcome to this webinar. And I'd like to introduce you to Phil Whenua and Tānira Kingi, who will talk about the work that they're doing in a project called Takahuri Whenua, the Changing Land Collective approaches to systems and land use change. So this is a specific piece of work from the New Zealand Agricultural Greenhouse Gas Centre that focuses on Māori agribusinesses and Māori primary production, land-based production, and it's a fairly rare beast, it's fair to say, but together, Phil and Tānira have been working on this for about the last 7 years, so we're privileged to hear what they have to say. So just introducing Phil in the first instance. So Phil is a consulting agricultural economist at AgFirst. His work involves economic research and analysis, agricultural extension services, and tech transfer. Phil has been working with the NZAGRC, the centre, for the last 7 years in modelling on farm mitigation, offsetting as to their impact on greenhouse gas emissions and profitability. And he is a life member of New Zealand Agricultural and Resource Economic Society. Tānira, I've worked alongside Tānira for a number of years, early on in our work at AgResearch, and so Tānira is a research advisor and emeritus scientist at Scion, which is a Crown Research Institute. His research is focused on developing multi-model frameworks that assess the economics and environmental impacts of land use change to meet environmental regulations. Tānira has been appointed to several government advisory groups on land and water policy development and is currently a commissioner with the Climate Change Commission. After the presentation, we'll take time for a question and answer, and please submit your questions to Phil and Tānira as we go along. And so at this time, ka hoa te toko ki a koe, Phil. The stage is yours, Phil, to present your presentation.
Kia ora, Chris. E mi mai rā ki a koe e whakatūwhara ai a tātou hui. And thank you everyone that has joined us for this webinar this afternoon. I'd like to start first with acknowledging the team, the research team from Scion, Fruition Horticulture, Ground Truth Limited, and of course AgFirst. The presentation is an overview of the program that is still in its first year. So we don't have any results, but we'll draw on some of the previous work that we have produced over the last 7 years to show you how we've developed this program. We've split the presentation into 2 parts. I'll give the outline of what we're doing and where we've come from, and then I'll hand over to Phil, who will outline the modelling approach that he's developed to estimate gross and net emissions and changes in EBIT or profitability on farm. Okay, so Essentially, Takahuri Whenua is a decision support framework that's got several models or tools that work inside it. The methodology that we use in the program that has been developed over the past 6 years is fairly straightforward. We start off by using maps of the farm, and we use ArcGIS for that to model both the current and future scenarios. We then use a tool called FarmX, which is used to model the production systems to estimate the changes in EBIT or profitability. We then, at the same time, we also use a tool a model called Overseer, which estimates greenhouse gas and nutrient emissions. And then forestry sequestration is done through a model called Forecaster. For horticultural crop options, we rely on a range of models and tools that we can get access to. And new options like plant proteins and tree crops, they don't have a lot of data, so we take the best estimate approach to start the discussion with the landowners. And I'll come back to alternative land uses later in the presentation.
Nira, share your screen.
Oh, is it not shared?
No.
Oh, excuse me. Let me just. Sorry about that. Well, thank you, Phil, and apologies, everyone. Can you see it now?
Yep.
Okay, just a minute. I'll just have to
We can see it
reset
now.
myself with that. All right, so this is the first slide that I gave the introduction to. The next slide where I outlined the tools is now in front of you. And the third slide that I'm about to move on to now, and apologies for that hiccup, is this one there. And I just want to talk about the regulatory environment and owner expectations that are in front of landowners now, or historically and in front of now. So there are several pieces of legislation in New Zealand impacting on the primary sector, including freshwater regulations, carbon regulations, that both of those will be introduced in 2025, and also resource management legislation reforms that are underway now as well. But in addition to that, Māori landowners also face increasing pressures from owners for their ancestral lands to be used in ways that are consistent with what they value. And also, COVID has highlighted the need for these organisations to play a much clearer role in supporting the social and cultural needs of these communities. I've also made a note on the slide there around some aligned programs that we have funded by our Land and Water National Science Challenge, which look into the influences of values and Indigenous knowledge, or mātauranga Māori, on land use. There's also our program is also linked to a much wider climate change agenda, and our program focuses on 4 areas, but these can be summarized in really 3 statements. And one is that what we aim to do is to be able to provide information to landowners on how they can reconfigure their farms by looking at their mitigation and land use change options. How to optimize their farms to accommodate these changes, But we also prepare farmers to understand that systems optimization and land use change are only two tools in a much wider toolbox to reduce biological emissions. And these include vaccines, inoculants, improved genetics that are underway now, and being developed and adapted to New Zealand conditions, but also being developed locally as well. And a critical component is an effective pricing mechanism on carbon, which is currently being consulted on around the country now. And this prepares landowners to look forward and to better position themselves for the future. We have, the structure of the program has 3 groups of partners, and we're working with 3 collectives based in different regions of the North Island. The first is is the Tūwharetoa Farm Collective in central North Island around Lake Taupo. Te Aroa Aratoa, also known as the Te Aroa Primary Sector Group, or TAPS, is located from the coastline of the Bay of Plenty to inland, and also the Whangara Farms, or Whangara Farm Partnership, located on the east coast. And the steps to the program is that we, once we've gone through agreements with both the collectives and the individual farms, the 3 collectives, and each collective has 6 farms that we're working with, so 18 farms in total. We visit each farm to confirm the data. We model the 6 farms using the methodology and the tools that I talked about before. And then we report back to the governance groups of each of these organizations. And for our international visitors here, the majority of New Zealand farms are owner operated or owned by individual family units, individual business units, or owner operators. But for the Māori sector, the majority of the land is tribally owned and have organizational structures that are elected or appointed by the owners. So they're effectively farms that are run by boards of directors or committees of trustees, etc. So we're working with both the trustees and the directors of these organizations, plus their management teams. We then look at reporting back to we report back to each entity, and then we bring the collectives together to all of the collectives together to look at identifying how we might be able to work collaboratively across the 3 regions and across the 3 collectives. So just going back to where we have come from in the program, we started in 2014, and the first 3-year program had a couple of parts to that. One was to estimate the emissions profile of 29 farm entities. It was originally going to be 30, but one of them pulled out for a number of reasons. We then identified and worked with 4 farming entities in different parts of the country, 2 livestock, 2 dairy, to develop and test the methodology. And right now, there is work underway by different groups to define the emissions profile for the entire Māori sector. So we've got to a point now where the policy development in New Zealand really needs to have a much better understanding of what the Māori sector looks like. And then if we had more time, I'd be able to provide a more detailed description and insights into the Māori sector, but we'll just move along with this current presentation. So included in that first stage was the the first time that we linked emissions and the emissions and financial models with the GIS spatial maps to show current and future scenarios. So we were still developing the methodology back then, and it produced information that we were able to put in front of these farming entities for them to look seriously at options that they had considered. And for this example that you've got in front of you, they made a decision to move into intensive beef production on a smaller footprint, and then offset that with forestry. And you'll notice in there, if you can see the slide, that the carbon price at that time was around $10, but we were modeling it on $15. The current price is well in excess of that. The second, in between, this is our stage 3 program. In between stage 1 and stage 3, we looked at modeling 2 organizations, 2 farming entities that had already diversified. And they were well diversified. They were very well known entities from within the country. And what we wanted to do was to understand their reasons for diversifying and what drove the owners to develop a diversified portfolio of land uses among those 2 entities. The third program, or the third stage of our of this research program, which finished in 2020, was again 2 case farms, 1 livestock, 1 1 dairy, and we were looking at what systems changes and what land use changes were needed to meet our 2030 methane and nitrous oxide targets. And for nitrous oxide, which was the 2050 target, we modeled them on a 36% reduction in nitrous oxide, not the 33% that's in the slide. The systems changes, like including the need to reduce stocking rates. One of the things that came out of this program was the need for good management skills to optimize the system, and that supported the need for farmers to make contact with industry organizations to link in with current programs on extension and information. But one of the key messages that came out of that research was that achieving both the 10% reduction in methane and, more importantly, the 36% in nitrous oxide required increasing levels of land diversification. And so why is land diversification important? And then one of the questions that the industry is facing right now is what are the options beyond exotic forestry for exotic forestry for the livestock sector and intensive horticulture for the dairy sector. What we have looked at here is to be able to look at these alternatives and try to develop and extend our methodology to include those into our modelling and our decision-making framework. But one of the realities of this is that investment into alternatives requires greater investment into infrastructure, including processing, supply chains, and market channels for these options to be viable in front of farmers. So plant protein and biofuels, bioenergy, feedstocks are options at the farm level, but the lack of processing infrastructure and market channels is a real barrier. Our current program includes the assessment of alternatives, including arable and horticultural crops that can be grown on the 18 farms. We've also looked at animal systems like dairy sheep. And one of the discussions that we have is that while the raw product can be produced for feedstock, they can be grown. there just isn't enough supply chains or markets price signals to generate the interest. So, for example, the main supply of rolled oats in New Zealand comes from the South Island, and although many of our farms in the study in the North Island have experience in growing arable crops, they won't invest anything to put them into the ground for plant protein like oats for milk unless there is a supply chain. Excuse me, I'm just... Okay. So the integration of multiple land use changes along with systems changes is a core component of our research. And one of the key questions that are coming through our farms that we're working with is how do we run our farms in a way that are consistent with tikanga or our cultural values? And how is the responsibilities of the elected representatives as kaitiaki or guardians, or hungatiaki as we call them, how is that reflected in current land use? And these questions have been around for many decades since Māori land was cleared and brought into the productive sector. And so we're now looking at options that include the reliance on dairy systems that are close to estuaries and other waterways, rivers and lakes, to not only reduce greenhouse gas emissions, but also to reduce the emissions to fresh water. This includes assessing arable crops like oats or legumes for protein, but also looking at bringing back wetlands or wairepo, as we call it in Māori, and incorporating aquaculture into the system. For example, bringing tuna in or eels to provide another revenue stream while also protecting that fragile ecosystem, but bringing back wetlands into the farm spaces in New Zealand, because around close to 90% of them have been drained and converted into pasture and been lost. But these are difficult to model without the data. And I've got a slide there on residential development and what some of the farms that we have worked with over the years and are working with now have residential and commercial development options for their pastoral land. The modeling that we would do in that is to be able to, once the area of land is taken out of the livestock or dairy system, we then model a smaller platform for the agricultural system alongside any due diligence or any evaluation that the owners will be doing on residential development. And this is my final slide. So the question that I want to leave with you is whether scale advantage of developing supply networks across the collectives is a workable mechanism to not only diversify to reduce emissions, to optimize the farming systems, but to also be able to meet the cultural obligations of the landowners. The limits that are on high emission systems now mean that we need to change what we are doing and how we do it, with rising expectations of owners. And to be able to do more than just financial returns, as the previous examples show around using land for social and ecological reasons that align with cultural aspirations or cultural priorities. And being able to underpin the responsibilities of these governors as guardians. And we believe in this program that these problems are best faced and dealt with collective solutions. I'll leave it at that. Thank you, Chris.
Tēnā koe te rangatirai, tāmira, whakaputa mai tō kōrero, hei kina ki mā mātou. There is one question I have here at the moment, Tānira, and it's around the alternatives, the alternative land uses. And so biomass and biofuel supply chains are probably not where it's at the moment. They may be weak. So what about biochar production, which also calls to mind activated carbon? What are the opportunities there in Māori land to diversify into that space?
Yes, well, biochar activated carbon is something that's been underway in New Zealand, well, and internationally for some time. And there, as another source of revenue, yes, that's it is a viable option, but it's also something that aligns quite closely to shifting in a production system from where it may have come from and where it is now to something that's more environmentally or ecologically sustainable.
Ka pai. And I'll also have another statement. Plus, I guess it begs a comment from you. It's that integrating multiple land use changes, this for me ticks all our boxes as a people. What do we need to do to sell this diversification to the nation? At the moment, forestry is the best example that's given. Tēnā koe, Lorraine.
Hello, Lorraine. Good question. And, when I look back at where the New Zealand agricultural industry has come from, it's no surprise that this is where we have arrived at today, at this time in 2022. That we do have intensive agricultural systems, and we're designed to produce, and they're well-run agricultural systems, and we're designed to produce products, food products, in high volumes and high quality for predominantly export markets. And so the tracks have been laid for a long time, right? Over 100 years. The first exports of milk and meat were back in 1840, and so we've been on this track for a long time, and there needs to be a concerted effort to invest in alternative infrastructure, but that won't happen until we develop more examples, right, to put in front of the industry players and farmers, as well as regional government and central government. It's a process of awareness and understanding that there are ways of doing that. We need to be able to get as many of our land blocks trying these alternatives out. However, the risks are quite high for individuals to be able to do this on their own. Joining collectives does reduce it, but even then the risks are high if investment and regulations aren't changed to not only increase government subsidies or government investment into it, but to also attract international money and private sector money to build these new processing and to build this new infrastructure and to lay new tracks for the future.
So, and just on that, so Clinton asked an aligned question. It's about, the concept of collaboration across three groups and collectives. Is there also a model of the aggregated cost and opportunity to the participants and extrapolation to Māori whenua katoa, all of Māori land, that is the cost to the current system?
Kia ora, Clinton. If I understand your question, which I think is around how do we move this beyond the collectives and the individual farmers? Because right now the farmers get the 18 farms in our program get information on how well they're doing now and what options they can look at. And then we're looking at bringing those together into across the individual collectives and then across the 3 collectives. How do we get that out further? Again, I think it is around information. It is around sharing. These 2 collectives and 1 group that we've got in the program are not the only collectives in the country. There are a number around that have been established for some time, but there's also a number of groups and collectives that have been established by NPI's MABEX team. So the number of collective efforts have increased in recent years. Developing these, because what we've developed here is a network inside a collective and across collectives. If we're able to extend that network, get the information out, what we're developing here are models of alternative ways of doing things. And the scenarios have got both financial implications to them and the impacts on, or the changes in emissions. The cultural context and the social context will change as these models are applied in different parts of the country.
Awesome. There's just another question about how did you choose the collectives? Is there criteria that you use, you know, whether they're ready to go, they've had the conversation themselves, they've got people that have been asking, and they've been doing some research or exploration themselves? What qualifies them to be involved in this forward-reaching research?
Yes. Yeah, good question. We did have a set of criteria. I didn't put them up, but it was around having a governance structure and management in place, or management team in place, being able to have the data available that we could access to develop the models itself, to have a management team that if we were able to put out options or alternatives, you know, were they able to discuss those options among themselves without us, the research team, being there. They're also, and if the question was asked by an international attendee, all of these collectives, all of the organizations in it, and almost all of the individuals in the governance teams are known by key players, Phil Whenua and myself and the team. And so we do rely on our networks, but as time has gone on with this program, our networks have increased, and the network of the Māori agribusiness organizations in Aotearoa is a fairly close-knit community anyway.
So I'm just going to take one more question. I know there's some very good ones here which we may answer online, but this is one I would have asked myself anyway, but a couple of other people are asking it. How do we build capacity in our people to understand and drive this kaupapa? And is there an opportunity for Māori leaders to develop an educational program to share knowledge and power?
Yes, that's a very good question, and the capability needs to be built at different levels, or at multiple levels, I should say. One is in governance. I think the questions that we're dealing with now need to be asked by the governance, so the trustees, the directors, the committees of management of these organizations. And so being able to get diversity among the boards, right, is important, but because of the election processes that we have in our in Whenua Māori organizations, and quite often our post-settlement entities that run farms as well, they don't always open themselves up to younger members coming through. And one of the things that we've seen over the years in this program and in others is that diversity of views and diversity of backgrounds and skills in the governance groups is critical. But we also need to build the capability of our younger people coming through universities, and then we need to start with them in secondary schools, and to be able to build on the programs that they already have. So if they come through with arts degrees or any degree at all, the education starts in our in these kinds of programs in understanding the whenua, right? And there's different parts of that. One is to be able to understand production systems and the complexity of our agricultural, horticultural, forestry, cropping systems, but also for our people in our management teams and in our governance teams to also know the history behind their lands, their whenua, to understand and to be able to identify wāhi tapu, the wāhi toto, areas of importance that need protection as we look at developing and evolving our landscapes, right, into more diversified uses to make to meet these changing demands that we will have going forward. Not too sure if I answered that question adequately, Chris. We can come back to it another time if you like.
Some of the stuff you can't answer in one soundbite, I think. But ka ki tēnei wai ngā manuwhiri ka huri taku reo whakamihi ki a koe, Phil. So I want to cut across to Phil so we don't crowd him out with time. And it gives Phil enough time to talk about the work that he's doing in Takahuri Whenua, and then enough time for us all to ask questions on the tail end of that. So thanks for the questions that have already been put up. I think there's some really good ones here. So it's tempting to carry on, but kei a koe te wā e Phil. I hand it over to you at this point in time.
Kia ora tātou. Hi everyone. Just bear with me 10 seconds while I share the screen, get back to the presentation. So what I wanted to do is sort of pick up from where Tanira left off and talk more possibly around the technical side of the program. So as Tanira mentioned, we're working with 3 collectives, modelling 6 farms on each. So we've got 6 dairy farms and 12 sheep and beef farms across the collectives. With respect to the modelling, there's sort of 4 components, if you like. What we do is look at the farm system and how you can fine tune or adjust that, and the implications with respect to greenhouse gas and profitability. We also look at forestry and as to how that would sit within the farm, and how that works with respect to offsetting the farm emissions. Within this program, we're looking at 3 different forestry regimes. The first is production forestry using radiata pine. For our overseas attendees, radiata pine is our main production tree in New Zealand. It grows very well, sequesters a lot of carbon, and is our most profitable forestry system. We're also looking at other exotics such as cypress and how they work. And the third one we're looking at is indigenous or native forestry, which is much more of a permanent forestry regime. We're also looking at horticultural options. Again, Tanira's mentioned this in terms of which might vary between what I call broadacre arable through to permanent horticultural, such as kiwi fruit, pip fruit, nut crops, that sort of thing. So what we do is look at each of those in isolation, and then look at how potentially we can integrate these across each of the farms. In addition to this, We also do some spatial mapping on the farm, sort of mapping out where land use change is possible, just to, it gives a visual representation and helps the farmers understanding of what sort of land use change may be possible. And then we're also looking at the integration of these across the wider collective, and I'll come back to that in a later slide. So we look at the impact of the new system, as I mentioned, individually and in combination. So the key things we're looking at is the impact on greenhouse gas emissions, the impact on the farm profitability, and for many of the properties in sensitive catchments, we're also looking at any changes in nitrate leaching. And across each, we can also give an indicated level of carbon tax depending on pricing and liability assumptions. Again, for our international attendees, the intent at this stage is that from 2025, New Zealand farmers will face a carbon tax on their farming systems. So what we're saying to the farmers is that we're not necessarily offering direct solutions. The idea is to present a range of scenarios, and we may look at anything, say, from 6 to a dozen scenarios on each farm. When you get down to it, there's probably 1,001 permutations that potentially you could model through. So the idea of the program is really to give the farmers a good idea of these scenarios and possible options, which they then need to think through and think how mixes of those different scenarios may or may not suit their particular farming operation. Now, just to show you some of the results that we're getting, these results in terms of this slide and the next ones are not from this particular program, because we're right in the midst of doing the modelling as we speak. But that was really just to give you some idea of some of the scenarios that we've looked at. It's not the full range, it's just a sample there, but it gives you some idea. I'm not going to run through the results, we'll be here for ages. But really, again, it's around looking at how we can adjust to fine-tune the farm system. One of the farms there, how we've added in kiwi fruit as a horticultural option, and again, also how we can add in forestry and how that impacts. This particular slide is for dairy farms. So adding forestry on dairy farms does tend to have a big impact on profitability. So as I say, we'd run through all these scenarios and present them to the farmers and discuss through the issues and implications. The next thing, this is basically the same, except this is for sheep and beef farms that we've done. Again, just a sample of farms and some of the scenarios. Again, you can see a number of things there around adjusting and changing the farm system itself, and then also building in forestry operations within the farm. In a general sense, most sheep and beef farms have probably got more option around forestry than your average dairy farm. But certainly, just to pause there for a moment, one of the big drivers, or one of the key drivers of greenhouse gas emissions on farms is the amount of dry matter eaten. So one of the key things we've been looking at is how do you reduce dry matter eaten, which is really around drop in stocking rates, and in which case you need to then look at improving the productivity of the remaining animals to make sure the farm survives financially. Most of which is not a short-term exercise. Many of these things would take up to 5 to 10 years to implement and feed in. The next one here is a couple of years ago, we looked at two multi-enterprise Māori operations where they had 2 or 3 dairy farms, sheep and beef farm, and a forestry unit. So we looked at scenarios to mitigate emissions on the individual farms, and then how they might mix and match that across the wider enterprise. And part of the reason behind showing you this, if you like, this is a sort of a micro example of what might be possible at a collective level. So when you look at the collectives, they may have, let's say, a dozen or so farms. So you can then look across. So instead of 12 individual farms, you've got one big farm with 12 components. So you can look across that and say, okay, this land use is perhaps best suited. We'll put in production forestry. Here we'll put in some indigenous forest there. We'll extensify the farm system in another part. We'll intensify, on another couple of farms, and perhaps we'll put half of this farm in some sort of horticulture. So it's this whole idea of sort of mixing and matching across the wider collective in order to get the best result. So in terms of the process we've met with and visited all the farms. Initially, we had a meeting with each of the collectives and sort of discussed through climate change and greenhouse gas issues and the sort of things and implications they need to think about. We've visited all the individual farms to collect the data, have a look at the lie of the land, talk with the farmers in terms of their ideas and possible scenarios. So we're currently, as I mentioned, right in the midst of doing all our modelling, which we will have finished by the end of March. The idea then is to go back to the individual farms initially to talk through, what we've modelled and where we've got to. Following that, meet with the individual collectives to discuss the results at a collective level. And then in the next financial year, what we want to do is use those results to do some sort of preliminary modelling at a collective level, as I mentioned earlier. So how might you mix and match these changes across the whole of the collective to get the best results, both in terms of reducing greenhouse gases and maintaining, if not improving, profitability. And having done that, what we want to do is then have a sort of pan-collective meeting with all three to talk about how they might potentially work across the collectives as a whole. And we've also got a program, we've got two collectives that are sort of watching this with interest, and we'll be meeting them next year to again walk them through what we've done and things they need to talk about, need to think about rather, and how they might organise themselves. So that's pretty much myself, as I say, as a quick sort of walkthrough on the technology side of things. So again, back to you, Chris, and open it up for any questions.
Yeah, kia ora. Thank you, Phil. I'll start off with a light one. So this one talks to restoration of wetlands versus sheep and beef farming, and asking, can you confirm that there would be a net what's the word? Net reduction in emissions by increasing the restoration of wetlands versus just sheep and beef farming?
Slightly complicated question that. In terms of the wetlands, probably the main advantage is in reducing nutrient flows and nutrient leaching, rather than reduction in greenhouse gas. And as an aside, wetlands can be a source of methane with all the decomposing organic material, so you need to be careful.
Yeah.
But as part and parcel of that, you can also look at planting up areas, say Kahikatea, which then moves you directly into the area of sequestering carbon and reducing new greenhouse gas.
Thank you.
Just,
And now a bit of a
sorry,
country
Chris.
Oh.
Sorry, Chris. Just the other part to that question is that there's a lot of historical wetlands that have been drained and used for pasture, right? Some of them can be converted to high producing pastures, but others, because of the underlying wetness of the land, will continue to be low producing. Now, if that area of wetland has livestock on it, you remove the livestock, you fence the wetland, you remove the livestock, and potentially reduce the amount of livestock you're carrying because of a reduced area of feed production. You will see a change in your carbon balance.
Yes.
Now a bit of a crunchier one that speaks of the work that you're doing in Māori agribusiness, but also with a mind to non-Māori businesses, so businesses that don't have farms that don't have perpetual ownership structures. So Charles is asking, can these scenarios support non-Māori whānau who don't have the perpetual ownership structure, and how long a time frame should we be modelling return on capital, return on investment for this type of land use change? And I guess the follow-on one is, can the current financial institutions cope with changing with all this as well?
So, look, I'll have a first crack at that. I think, firstly, while we have been working with Māori farms over the years, and now we've extended it to Māori collectives. The modelling framework that we've developed can be used on any land ownership system and land ownership structure. It is transferable because the tools that are in it are fairly standard tools. So it can be applied to farm owners that have different investment horizons and have different priorities, because what we are producing are land use change scenarios and production systems scenarios that meet their objectives, whatever those objectives might be.
Okay, and Phil, I have one specifically for you.
Sorry, Chris, can I just go back to your earlier question?
Yep.
In terms of the capital input and that sort of thing, we do take account of that in the sense of using forestry as an example. Production forestry is say a 28-year investment. So we'd look at the capital investment, cash flow over that 28 years, discount that back to bring it to an annuity level. And we do exactly the same for horticulture. And some of the horticultural crops, as the New Zealanders would know, there's very significant capital input. So we take that into account when calculating the profitability of that operation, which we build into the model.
Awesome, that's very clear. I have one specifically for you, Phil. And Ko asks, do you have a look at the environmental impacts for a group of farms in addition to scenarios for individual farms, or the potential for a peer-to-peer learning to reduce greenhouse gas emissions, as well as nitrate leaching? And Overseer FM enables this in its farm group aggregated benchmarking reporting functions, which would be useful for facilitating conversation with amongst farmers. It's a long one.
Yeah. Well, I guess the short answer is yes. Certainly, I think one of the side benefits, if you like, from our previous programs in this one is that it gets the farmer understanding of particularly greenhouse gas issues becomes much clearer, and they certainly talk amongst each other. I think the results that have flown out of the programs that our team have been running has been picked up amongst some of the wider farming community. And in a number of areas, where water quality is a sensitive issue, that question of nitrate leaching is a big one. So again, if you like, you're mixing three components. You're looking at what am I doing to my greenhouse gas? What am I doing to my nitrate leaching? What am I doing to my farm profitability? So you have to balance all three. And again, I think, Chris, you know, the learning from that is slowly starting to be picked up in a sort of peer-to-peer type way.
And do you think as we enter further into the conversation that peer-to-peer learning, or that transfer of knowledge from, say, the large collectives that Tānira and yourself are working with, to those that aren't so directly involved, that there will be some kind of increase in the learning and sharing, and the systems to enable that will become better?
I think so. I mean, if you look at the extension side of things, most farmers learn from other farmers. And so, if you like, we're starting working with groups of farmers. They've started on their journey, and people will be looking over the fence and observing that, and talking to the farmers who've started on that journey, and in that way, you know, the information starts to flow.
Yeah. Okay. I have one from Ina that talks about climate change and how do you assess the impact of this performance on various land uses, crops and pasture types? Good question.
Well, yeah, good question. I guess as part of the program, we're not at this stage. We're not really looking at that and saying, okay, you know, in 20 years you can't do this particular sort of farming in this area or on this piece of land, simply because there's a limited amount of information available. But certainly at a wider scale, we're saying if you look at the implications of climate change, then the top half of the North Island is probably going to be subtropical. Now that has huge implications for our farming system. And I was talking to some dairy farmers the other day, and they said, in 50 years, will we still be dairy farming? And I would argue, yes, you will, but you'll be milking zebu and sahiwal cattle, and you'll be feeding C4 pastures.
Right. And so given the investment that you need to put in now in order to change, it sort of begs the question, is more effort required in understanding climate change to overlay it on land use change or transition to different land uses, and investment is more research required to understand what climate change how it will impact us?
I think there's a very short answer to that, Chris, and it's yes.
Cool, thank you. I have one about Nutrientcycling, recycling. So do you think about nutrient recycling in these systems, and how an effluent or carbon production could be consumed in another part of the farming or land use system?
Well, yes, I think that's part of it in terms of nutrient cycling, with respect to, you know, effluent management and that sort of thing. So you're spraying the effluent back on the pasture and using it in effect as a fertilizer. I think in terms of carbon cycling, that's sort of part and parcel of the offsetting. So, you know, for example, you're emitting carbon from a pastoral operation, but you're recycling that back through your forestry operation.
Hapai, and Bano, we have 1 minute to go. But there's one question I'm interested in myself before that minute dies out, and that's assuming Māori farmers, and this is to you, Tānira, I guess, assuming Māori farmers change systems and infrastructure to reduce their carbon footprint, are there mechanisms to capture the carbon credits?
Yeah, so there are two parts to that question. One is reducing your gross emissions by changing your livestock component, either by reducing stocking rate, reducing area, or both. And so your the reduction in your gross emissions can be measured and accounted for. The other part to that is sequestration, and I mean, at the moment we have the Waka Econo sequestration formula that is now in circulation and consultation. It's not the same as the ETS, It does provide a different carbon balancing formula for you, because it accounts for sequestration on trees and crops that aren't accounted for in the ETS. If you invest into horticultural crops or tree crops under the current ETS, many of them are not eligible for carbon credits under the He Waka Econo formula. They are counted to derive or estimate the total or sorry, the net emissions from your farm operation, offsetting your emissions from your animal system.
Thank you, Tānera. Well, kua tai ki te wā, I aku rangatira, kua tō te rā ki rungi tēnei kōrero. We've come to the end of the webinar, but the recording will be, and the presentations will be uploaded onto the Greenhouse Gas Centre's website within the week, and we will endeavour to answer the questions, because there's some very good questions here. And of course, this is just the beginning of a conversation, given that this is probably the first piece of work off the rank in terms of greenhouse gas research on Māori agribusiness. So there's a lot more to go, and no doubt you'll hear from us again as more research comes into play. Tānera and Phil complete the current work that they're doing, so there's plenty of opportunities. I wish it was within the next couple of months, but it's probably going to be a longer time frame than that. But however, I aku rangatira, tēnei rā te mihi kia koutou, I ngā kau nui ana ki tēnei mahi, he toha, he koha kōrero mā tātou, he wānanga, he pito kōrero. Thank you very much, Phil and Tānera, for sharing your experiences and giving us a platform to ask questions, knowing that it's a really important kaupapa that's unfolding, and that we need to have Māori on board with climate change, greenhouse gases. We're at the beginning of it, but very important kaupapa. So thank you all for joining us. Our guests from overseas, it was an honour to have you guys here, and also our experts amongst the audience, and our contributors and people that ask questions. So thank you very much. Tēnā rā tātou katoa.